Welcome back to Geometric Virtual Learning. This is lesson 2 on similar shapes, where we talk about calculating missing area and volume of similar shapes and also finding missing length of similar shapes. I welcome new viewers also. Scale factor can be calculated from two corresponding units of measure. What that means is that you can use corresponding area to work out scale factor, corresponding volume to work out scale factor, corresponding length or height to work out scale factor. But the format will be depending upon the units you calculate your scale factor from. So, K is from finding missing length. So when you work out scale factor from missing length, it's called K. K squared is used to work out missing area, and K cube is for missing volume. So you need to make sure your scale factor is in the right format. Now there are some dynamics that you need to understand how to change from K squared to K. So I've just written something for you to help you understand what to do, and I will be using them in my example to explain to you what I mean by that. So you can just make a quick note of what I've just done. All I'm trying to show you is, if you have the format as K squared, if you want to use it for missing length, change it into K, you find the square root. If you have it for missing length and you got a K and you want it in area, you have to square it, and so forth. So it's just an inverse. The only thing you need to be sure is where we have to do movement. K cubed, cube root to K first, then you square it to use it for area. If you have an area format and you want to use it for volume, you square root to get it for K and you cube it before you use it. I'm going to make specific use of these in my examples. We have two prisms A and B, height given, volume of B given, but volume of A is what we're supposed to work out. So here, if you check, the only corresponding measure you have is the height, and that's what you can use to work out your scale factor. So first is work out scale factor of any two known corresponding sides. So your scale factor is a K because you are using it for height, or you get it from height. So 30 over 24, simplify it, but please don't change it into a decimal. It makes it easier to work with fractions. So it's 5 over 4. Now you want an answer in terms of volume, so our K needs to change into K cube. Therefore, we need to cube our scale factor. And that's what we have. Also leave it as a fraction. We want the volume of A. A is the smaller shape. So given the volume of bigger shape B, we have to divide the volume by the scale factor. And dividing by 125 over 64 is the same by multiplying 500 by 64 over 125. And the answer is 256 centimeter cube. So this one is an example for finding missing volume of a smaller shape. Let's look for volume of a bigger shape. We have the volume of the smaller one, 576 meter cube, height of the two given. So we start with scale factor of known corresponding units, which is the height, and obviously that will represent K because we are using length or height. We want the format in K cube because we are looking for volume. Cube your scale factor. So we have 729 over 64. We are looking for volume of B, which is a bigger one. So we need to take the volume of A and multiply it by 729 over 64. And that will give us 6,561 meter cube. So it's just the dynamics, knowing how to move from K to K cube and so forth. That's why I gave you those kind of movement for you to understand. Pause this video and see if you can work out the volume of cylinder X. Volume of Y is 18 liters. Work out the volume of X. When you're ready, click play. Okay. First, work out scale factor of two known corresponding sides. The height is the only two known side we know. Scale factor is 5 over 2 in simplest form. 15 over 6, 5 over 2. That is, divide each side by 3. We can use K for volume. Remember, liters is volume. So we need to change K to K cubed. So we have 125 over 8 as our scale factor in volume. We want a volume of a smaller shape, so the volume should be divided by the scale factor. And that will give you 1.152 liters. 1.152 liters. Okay, next example. Here we are looking for missing area of a bigger shape. So surface area of A is 504 cm squared. So A 504 cm squared. We want to work out volume of B. Let's check out known corresponding units. Is 12 and 9. So we can work out our scale factor, that is K. We want our answer in the format of square, so we change K into K squared. K squared is 16 over 9. As I said before, always keep it as a fraction is best that way. We want an answer for a bigger shape, so we need to multiply the volume, the surface area of A by our K squared, which is 16 over 9, and that gives us 896 centimeter cube. 896 centimeter cube. So this is the example for working out missing area of bigger shape. What about the reverse? Area of a smaller shape. So we have two pyramids, A and B. Height of each given. Surface area of the bigger one giving us 800 cm squared. We want the surface area of the smaller one. Use two known corresponding sides to work out surface scale factor. And obviously it is our K. Simplify 10 over 4 divided by 2 as 5 over 2. Change K into K squared to fit the area format. We have 25 over 4. B is bigger. 800 is for the bigger one. To get to a smaller one, we divide 800 by the K squared scale factor, and that gives us 128 centimeters squared. So these are the dynamics of changing from scale factor to another scale factor depending upon what is required. Now, here is where we have lengths and want to move to work out volume. So we have a volume. So we have to find missing lengths given volume. We have a volume of A 27 cm cube, volume of B 125 cm cube, height of A 12 cm, height of B is what we are supposed to work out. So we start by working out our scale factor. What are the two known units that we have? Is the volume. The volume are the two corresponding units that we have, so we work out the scale factor using the volume. And that is K cubed because we worked it from volume. We want our answer as height, so we need to change K cubed into K. And to do that, we need to have a cube root of K cubed. And that will give us 5 over 3. 5 over 3 is in the format K that will lend itself to be used to work out missing lengths. And one height on a bigger shape, so the corresponding size should be multiplied by our scale factor. So 12 by 5 over 3 is 20 cm. 20 cm. Now, this is another typical exam question. Take a minute to read the question. Cone A and cone B are mathematically similar. The ratio of volume of cone A to cone the ratio of volume of cone A to volume of cone B is 27:8. The surface area of cone A is 297 cm squared. Calculate the surface area of cone B. So this is a mixture of volume and area. And we are supposed to work out the area of cone B. So it's best to go step by step. So we have A and B. 27 is to 8. 27 is to 8. That is the volume. 27 to 8. Now, scale factor of volume using this is 27 over 8. 27 over 8. So I'm just using the volume to work out the scale factor of volume. You need to understand that we are supposed to work out area, so we must change volume into length, then from length into area. From the initial slide that I showed you, you can't use k cubed straight into k squared. We need to get to k first. So to get to k, we find the cube root of these numbers. That will give us 3 over 2. So that is k. Now that we have k, we can now change k into k squared. So k squared will be 9 over 4. So we know k squared now. So if the surface area of cone A is 297 cm, we can use it to work out B. So, given that the surface area of cone A is 279 cm squared, surface area of cone B, and if you look at this carefully, cone B is smaller. As you can see from the ratio, cone B is smaller. So we need to divide A by the scale factor k squared. And that will give us 132 cm squared. And that brings us to the end of lesson 2 on similar shapes. Look forward to lesson 3, where I'll be talking about ratio and similar shape. The use of ratio and similar shape in exam style question. Thank you very much for watching. Please share with your friends. Thank you.